I'm recording right now, guys. We will review chapter 8 by doing the end of the guided notebook exercises that I made available. There were 5 of them. I did number 5, so I'm going to do yesterday. So I'm going to do 1, 2, 3, 4. And then go to the exam 3 study guide and do some more questions pertaining to chapter 8. Question 1. Dr. Smith would like to determine if there is a statistically significant difference between her 2 math 1800 classes. To make this comparison, she will compare the results from exam 1. Class 1 had 33 students, so let's start writing the data that we have right here. So class 1, let's see what she has in for class 1. Had 33 students, so N1 is 33. And with a mean of 82.6. So X1 bar, guys, is 82.6. And with a population standard deviation, you see it says population standard deviation. Don't mix it with a sample standard deviation. So you know it's a z-test now. Sigma 1 is 1.41. Then class 2 had 31 students, so N2 is 31. And then it's going to give you the sample mean, definitely, with 84 and a population standard deviation of 3.63. Can Dr. Smith conclude that there is a difference in the mean testing grades between the 2 classes at alpha equals 0.05? It's obvious. He's asking you if there is a difference. So you guys, you're testing if mu1 is different from mu2. And this is where your claim is. And your null hypothesis will be mu1 equals mu2. Now, because sigma 1 and sigma 2 are known, we need to do 2 sample z-test. And again, why? He gave us sigma 1 and he gave us sigma 2. So let me run the 2 sample z-test and write the results, guys. You go on, turn the calculator on. Let me just move this away. Stat, tests, 2 sample z-test. No data here. I have a summary. Stats. Okay, sigma 1. So we say sigma 1, what was it? 1.41. Sigma 2 was 3.63. X1 bars was 82.6. 33 students. X2 bar was 84. And N2, we had 31 students in the other class. And we're testing that mu1 is less different from mu2. Make sure to select the alternative sign, guys, and press enter. Otherwise, it will not be selected properly. And then scroll down and hit calculate. Okay, it is a 2 sample z-test. Z is negative 2.009. Which is, if you round it to 2 decimal places, it will be negative 2.01 right here. And the p-value is 0.0445, which is less than alpha. Alpha is 5%. So we reject the null hypothesis. And if we reject the null hypothesis and your claim is in the alternative, you should know by now that you support the claim. So we reject HO and the claim is in HA, we support the claim. There is enough evidence at the 0.05 level of significance to support Dr. Smith's claim. Okay, any questions here? Number 2. A survey found that the average hotel room in New Orleans is $88.50, and the average room rate in Phoenix is $84.75. Assume that the data were obtained from 2 samples of 55 hotels each, and that the population standard deviation, see I put it between parentheses, were $5.60 and $4.83 respectively. At alpha equals 5%, can it be concluded that the average hotel room in New Orleans cost more than in Phoenix? So we have New Orleans, which is set 1, and then Phoenix set 2. So let's just do that here. Okay, so what do we have? X1 bar, 88.5. And he gives you sigma 1, guys. He says population standard deviation, $5.60. Then we go to Phoenix. What was the cost in Phoenix? 84 and 75. And sigma 2 is $4.83. And both N1 and N2, guys, is 55. He says 2 samples of 55 each. Can it be concluded that the average hotel room in New Orleans cost more? So we want to check if in New Orleans cost more than Phoenix. And New Orleans is going to be labeled as a mu1, and Phoenix is a mu2. So guys, you need to check this hypothesis, that the mu1 is bigger than the mu2. And the null hypothesis will be this. This is your claim. Okay, it is a 2-sample z-test again. And if you ask me why z-test, because he gave me sigma 1 and sigma 2. Stat, tests, 2-sample z-test, and let's run the test. Enter. Now let's enter the data. Sigma 1, which is 560. Sigma 2, which is 4.83. X1 bar, 88.5. X2 bar is 80, size is 55. X2 bar is 84.75. And N2 is 55 again. And we are testing that mu1 is bigger than mu2. And hit calculate. So I got Z to be 3.76, and look at the p-value. There is an E minus 5 next to it. That means you have to move the decimal 0.5 digits to the left. So let me write them down. When the Z is big, the p-value is going to be very small. And the p-value, guys, will be 0.00005 5 digits, 847. 84. Which is, guys, definitely this is less than alpha. So we reject HO. Okay, same as above. We reject the null hypothesis, and our claim happened to be in the alternative hypothesis. We support the claim. There is enough evidence at the 0.05 level of significance to support the claim. And if you're doing your work online, it might ask you to select what the claim is. The claim is that the average hotel room in New Orleans costs more than that of Phoenix. Any questions? No questions? Okay, question 3. So these are a section 8.1 review, guys. I think we're heading now towards section 8.2 now. All right. A real estate agent wishes to determine whether tax assessors and real estate appraisers agree on the values of homes. A random sample of the two groups appraised 10 homes. Is there a significant difference in the value of homes of each group? Okay, it's obvious. He says significant difference, so it shouldn't be hard for you guys to state the null in the alternative hypothesis. Mu1 equals mu2, and for the alternative will be mu1 not equal to mu2. And this is where the claim is. Assume that data are from normally distributed population, the population variances are not equal. When he says population variances are not equal, guys, he's telling you when you choose your calculator, select your calculator, pooled is gonna be no, because it says not equal here. It is a two-sample t-test. This is a hint for you to know it's two-sample t-test because he says population variances are equal, not equal. Once he makes this statement, it's a t-test. So we'll be using a two-sample t-test. Okay, let's run the t-test together. Stat tests, two-sample t-test. It's a summary. So X1 bar is number 3. It's 83,256. S1 is 3,256. N1 is 10. X2 bar is 88,354. S2 is 2,341. And finally, this is 10 here. For tests with an alternative hypothesis is not equal to. You see, this was selected before. You can't just do this. That wouldn't be enough. You still have to press enter. Now if you press enter, it is active. And then pooled is no, because he says population variances are not equal. If he says they are equal, you use yes. And calculate. Okay, so I got T to be negative 4.020. Let me write them down. P-value. You can see the p-value was, look guys, there's an E minus 4. That means you have to move the decimal 4 places to the left. It will be 0.00095, but if you round it, it will be 0.001, which is definitely less than alpha. So we reject HO. And if we reject HO and the claim happened to be in HA, we support the claim. So we write there is enough evidence at the 0.05 level of significance to support the real estate claim, real estate agent claim. Okay. Now question 4. A researcher suggests that male nurses earn more than female nurses. A survey of 14 male nurses and 22 female nurses. So 14 male nurses and 2 is 14 and 22 female. Report this data. Is there enough evidence to support the claim that male nurses earn more than female nurses? Use alpha equal 5%. Assume the data come from a normal population and the population variances are not equal. That means pool is no. This is a hint, guys, for you. This is a two-sample t-test. All right. I need your help for this one. This is HO and this is HA. Can you tell me what the signs are going to be here? We want to check if male nurses make more than female nurses. So what would be the signs?
Males is greater than. For HO, it would be males is less than or equal to females.
Okay, and then this one will be greater right here in the second one.
Yeah.
Okay, here's what I hear the students saying, guys. A student is saying you put the greater here and then less than or equal there. Well, unfortunately, I disagree. Why is that? You see, this problem was going to get a lot of students. Why? I said I disagree. That's not correct. If you do it, you'll be testing the wrong claim. We start talking about males, right, guys? But did you notice in the listing down there, he didn't list males to be first. He listed them to be second, number 2. And number 1 is the females. If you test mu1 greater than mu2, guys, you will be testing the claim that the females make more than the males. It just happens, I intentionally did this, guys, to show you that the labeling, sometimes, you know, just I can do the labeling any way I want. So I put the females first and the males next. But if the males make more than the females, that's what we want to claim. That means the females make what? If you start talking about with females first, if you put the females first. So testing the claim that males make more than females is the same thing as testing the claim that females make what? Less than males. So it should be a less than. Does this make sense, guys, or no? That should take care of this. So again, mu1, we put mu1 less than mu2 because we're testing that males make more than females, but because females came first labeled as 1, we need to test that the females make less than males. This is a 2-sample t-test because he gave me S1 and S2. We did the 2-sample t-test, and these are the results of the 2-sample t-test. When you get the test statistic, you get the p-value. We used pooled no because he says population variances are not equal. And you guys, this is a good chance to check your values and make sure that you didn't put anything wrong here. The calculator will try to confirm that your values are correct here. So the p-value was 0.0668, which is bigger than alpha. So we failed to reject the null hypothesis. And if we fail to reject the null hypothesis and the claim happened to be in the alternative, which I didn't put here, claim, then you say there is not enough evidence at the 5% level of significance to support the claim that male nurses earn more money than female nurses. So this claim probably it's not valid, okay? Then yesterday we did the dependent samples. We did this question. I'm gonna do another question from section 8.3 from the study guide for the test, guys. So let me just take you there. But before I do that, let me just go over the chapter 7 assignment. You had 2 questions only to answer. The first one is a psychologist believes that the mean age of which children start walking is 13 months. The following data is given. Test at the 1% level of significance if the mean age is different from 13. You follow the question, guys. The question is asking you to test if it is different. So you put mu equals 13, mean is not equal to 13, and you run a t-test. You put this data in L1 and you run a t-test. I already worked out the solution. I will make it available to you. For the second one, a sample of 800 items produced on a new machine showed that 48 of them are defective. The factory will get rid of the machine. There should be an off here. If the data indicates that the proportion of defective items is more than 5%. At a significance level of 10%, does the factory get rid of the machine or not? So here, guys, we need to test that the proportion is more than 5%. If it is more than 5%, we get rid of the machine. So this is the claim. And the null hypothesis will be less than or equal to, and this is a proportion test, guys. 1 prop z test. Let's do it. So here you go. Turn the calculator on, go to stat, tests, 1 prop z test. There you go. So we're testing the value in the null hypothesis 5%. X is 48, N is 800, and we need to test that P is bigger than 5%. So this is the bigger one. And then go to draw, if you like. Okay, so Z is 1.2978. If you round it to 2 decimal places, it will be 1.3. And the p-value is 0.0972. There you go, which is less than 10%. So you reject the null hypothesis. If you reject the null hypothesis and your claim happened to be in the alternative, you support the claim. So there is enough evidence at the 10% level of significance to support the claim that the proportion of defective items is more than 5%. Should the factory replace the machine? Yes, because we did support the claim, so they should get rid of the machine. I could be giving you this very same question, guys, on the test, but instead of 10%, I change it to 5%. What will change in this problem if I change this to 5%? Would anything change? Nothing will change, or what? Any ideas? If alpha was 5%, what will happen to this step number 3? Any thoughts? Yes?
Can you repeat the question? I'm sorry.
I said if I change alpha to 5%, how would you do this problem? 0. And here will be what? Bigger than alpha, correct?
Yes.
So you fail to reject HO. Look how alpha makes a big deal, guys, in the problem. So be very careful. You fail to reject HO, then you will say there is not enough evidence to support the claim that the proportion is more than 5%. And then to answer the question, should they get rid of the machine? You say no, because we cannot support the claim that the proportion is more than 5%. What I want you to know, guys, just pay attention, please, to alpha. It does make a big difference in the problem. So that was chapter 7 assignment. This is the bonus assignment. I'm making the solution available to this one as well for students who did it. And now this is the study guide.
Will we be able to see our grade if we got the extra credit or not?
Yes. You know what? For the extra credit, unfortunately, the grade book doesn't have a place where I can put extra credit, but I can tell you, and then I'll add it at the end of the semester. But I promise you that it will be added definitely. The grade book doesn't have a feature where you can enter extra credit in there, so it's all regular assignments. This is the study guide, guys. It's about, I don't know how many questions, 20. You won't have as many questions, but this is just a study guide. You will have some very basic questions on the test, just to tell me whether this is a left-tailed, right-tailed, or two-tailed test, as simple as that. And you'll have mostly solving word problems with hypothesis tests. Can you answer, for example, the first question for me? What would be the correct answer?
Two-tailed.
Which one, C or D?
C.
What about D? D is wrong, guys. Why? Because we're testing, it says here you are testing the sample mean. We never test the sample mean. We always test the population mean. So when we do a hypothesis test, we either test this guy or P. We test sigma, but I made it an optional topic in 7.5. But guys, it's always about the population parameter. It's a mean or population proportion, but not X bar. I know X bar. What do I need to test about X bar? There's nothing to do there. What about number 3? So you are correct, guys. It is C. What about number 3? What's the answer? The
D.
D. I agree. What about 5? If we reject the null hypothesis when it is actually true, what kind of mistake did we make? What kind of error?
Type 2.
When we reject HO when the null hypothesis is true, it is type 1. Type 2, when we fail to reject the null hypothesis when it is false, so it is type 1. All right. Okay. These are the, so I will provide, you know, the answers, but before we get into chapter 9, I would like to do number 17 covering section 8.3, guys. I did it with the other group and I'd like to be able to do this with you. A pharmaceutical company wishes to test a new drug with the expectation of lowering cholesterol levels. 10 subjects are randomly selected. So what they did, they took their blood cholesterol before they took the medication, and they put him on the medication for 6 months. And after that, they took their, they tested their cholesterol levels as well. So we have a data before the drug was administered and after the drug was administered. This, when you see something like that, guys, then you know for sure that the samples are dependent. Dependent, what it is about the same subjects before an action and after an action. This is how you can tell if the samples are dependent. Test the company's claim that the drug lowers cholesterol levels. So what we do, guys, what we did yesterday, we do the difference. Between 195, the first patient, he went from 195 to 180. Does that mean that the drug worked, guys, or it didn't work? What do you say on this person? He went from 195 to 180. The manufacturer says it does lower cholesterol. So probably it worked, but not by that much. So the difference is positive here. This guy went from 225 to 220, 5 down. Okay, I don't know if this is substantial. This guy, it didn't work for him. Look, he was 202 cholesterol level, and then after taking the medication, went up. And what's the difference, positive or negative? It is negative. So it seems to me, guys, that we want the difference to be positive if we want to lower, if we want the drug to work. If the difference is negative, it seems like it's not working. And that's a hint for you guys. When you state the null and the alternative hypothesis, you know that you want to test that the mean of the difference is greater than 0. That's the claim. I know it defies, you know, just your intuition that it says lowering. A lot of students think the word lowering means less than 0. No. When you do the difference, lowering, you know, will have an opposite, you know, just impact. It will be greater than 0. So that's the difference, greater than 0 here. I mean, let me prove it to you again. Look, this guy had 195 reading cholesterol level before the drugs was administered, and now it's 175. If you do the difference, that's at 20. And it did work on this patient. It went down by 20 points. So that means the difference is positive. This guy went from 175 to 175, positive. No change here for this guy. This guy here, 235 to 205, went down by 30. Look at the difference is positive. So it does make sense that we're testing the claim that mu of D is greater than 0. Okay, so we're gonna run a t-test on this. Let's put this one in L1. Let's do this together, guys, and show you how I came up with the values there. So I'm gonna put them in a list. Let's put them together. So I got 15, 5, -8, 20, 5, 0, 30, 18, 0, 15. Another hint, guys, you can tell whether you need to do greater than 0 here or less than 0. Look at the pattern, the trend. It looks like mostly positive numbers, so very likely it's going to be positive here. That's what your claim is. Okay, so we go to stat, edit. Sorry, stat, not edit, tests. T-test. All right, and data. I put my differences in L3, guys, so I'm gonna just change that to L3. Mu0 is 0, and this is L3. You probably did it in L1, so just keep it L1 here. And we need to test that it is greater than 0, and then we do a draw here. It's nice to see the p-value in action. Oh, it's very small. So T is 2.75, and look at the p-value, 0.0112. But even small, I'm testing at alpha equals 0.01, guys, so it's bigger than alpha. You fail to reject HO. And if you fail to reject HO and the claim is in the alternative hypothesis, you cannot support the claim. There is not enough evidence to support the claim that the drug lowers cholesterol levels. Maybe you would tell me, but it seems like it's working for patients. Well, guys, going from 175 to 170 is not substantial. It's only 5 points. That's not, I wouldn't want to take a medication that would only lower my cholesterol by 5 points. It has more side effects than the benefits of only getting 5 points lower. So it has to be a lot lower than that. And that's why we could not support the claim. Okay, any questions here? Okay. All right, so any questions before I proceed to chapter 9, guys? All right. I'm assuming that all of you have intermediate algebra background. You learned about equations of lines. Let me just show you what I'm talking about here when it comes to equation of lines. You know how to sketch a line. This is the X and Y axis. If you have 2 points, for example, 1, 1, and you have another point, let's say right here, let's make it, for example, 4, 5. And then if you connect the 2 points, you get a line. So this is an equation of a line. And the line is written, guys, as y equals mx plus p. M is called the slope of the line. And B is called the y-intercept. The y-intercept is where the line crosses the y-axis. This is what the y-intercept is. Here's what we're gonna learn here. We have data from 2 sets of variable, x and y. And when we write a point or we plot a point on the coordinate system, the xy, we do it as an ordered pair. We put x first, and then we put y next. So the 1 here is x and the y is 1. X here is 4 and y is 5. How do I get to 4, 5? I start at the origin, guys. And you go 4 units to the right and 5 units up in order to get the point. If this was a 4, -5, you would go 4 units to the right and 5 units down. So this is what xy is. What I would like you to do now, guys, is just give you a minute to do this. I would like you to put the x values in L1, so input in L1, and I'd like you to put the y values in L2, and I'm gonna show you how the calculator can plot those ordered pairs for us as XY. So the calculator is going to show you 8 dots, guys. Why 8 dots? Because I have 1, 2, 3, 4, 5, 6, 7, 8. So would you please do that now? I'll give you a minute to just enter the data in L1 and L2. Resume recording. Okay. So you have L1 and L2. Here's what I like you to do. I like you to press the second key and then Y equals. You're gonna see this screen. If you don't see it, please let me know. And then I like you to press enter. Okay, you're gonna see this. I like you to select on and press enter. Then go to type and select the first one. So if your calculator was, for example, here, you need to move it back and to the first one, which is scatter plot. And make sure, guys, it reads here L1 and L2. If it doesn't read L1 and L2, let's say it says L1, L3, change L3 to L2 if you put your data in L1 and L2. How do you change an L3 to L2? You just press the second key and 3. Look, that's at L3 now. If I want to change it back, second and then 2. And then quit. How do you quit the screen? Just second and quit right here. This is from the previous screen. I'm going to clear it. Now watch, guys. Click on zoom and go to number 9, which is zoom stat, and hit enter, and you will see the points. There you go. If you count them, guys, there are 8 points. 1, 2, 3, 4. Imagine you're not just having to sketch those points by hand with decimal. It would take forever to get this done. So the calculator got it done for us already. Any questions on this? Now, my question to you guys, I like you to look at the X and Y values, the points, and please participate in this and tell me if you notice any trend here between the X and Y. Do you notice anything, any relationship between X and Y? If yes, what do you notice? If you don't want to talk, just chat, put it in the text box. What's your observation looking at the X and Y values? What do you observe? There is certain trend here. Can you tell me what that trend is? Any ideas? It's very quiet today. I don't know why. At least I have a few students who would participate with me. Does any of those students want to make an observation? What do you notice in here? No? Okay. I will do it. Not similar numbers. What happens as we move this way? X increases. What happens to the Y? It does increase as well. So there is a relationship. Yes. The relationship, guys, is as X increases, Y increases. That means they are related. X is related to Y by a linear relationship. Now, what do you mean by a linear relationship? It seems to me like those points X and Y belong to one line, very close line. They're not exactly on the same line, all of them, but there is a line that is called the line of best fit. If I draw it right here, guys, it seems like most of the points gather around this line. This is a line called the line of best fit. And when all the points gather around a line, then you can conclude that there is a relationship between X variable and the Y variable. So the trend, guys, that you notice is correct. As X increases, Y increases. I'm gonna write it down here. So what you learned now, if I give you order pairs, X and Y values, you should be able to do a scatter diagram and a scatter plot and show the points. This was done in static range, guys. That's why it looks slightly different from your calculator, but it's pretty much the same thing. Yeah, it is linear, as exactly as you said. The first number X is called the independent variable. They call it in statistics the explanatory variable. The Y is called the response variable. So Y depends on X. And X is independent variable. You notice as the value of X increases, the value of Y increases at a steady rate. Therefore, we say that the relationship between X and Y is somehow linear, meaning that we can almost fit most of the points on a line or closer to some line called line of best fit. That's what I just said. Okay. See, it's algebra. We're still doing a little bit of algebra right here. So here, these are the direction and how to create a scattergram, guys, using the calculator. So if you forget what I did, you can refer to this for the line of, and how to do the scatter plot. Okay. This line here, guys, is called the line of best fit. That means this is the closest line that you can draw as close as possible to all the points. And now, guys, I'm going to show you how to sketch this line, which is called the line of best fit, all using technology. So please pay attention here. And I'm going to ask you to do one thing. You do it once, and you don't have to go back and do it again unless if you reset your calculator, you need to do it at least for the final exam, because some of the questions from chapter 9 might be on the final exam. So we're going to do this on the calculator. If you don't reset your calculator, you don't have to do it again. So turn your calculator on, press the second key, and I like you to press the number 0. Why? Because that's going to give you an access to catalog. And look, this is my catalog right here. And I would like you to scroll down until you get diagnostic on. Watch. I'm almost there. Once you select diagnostic on, I would like you to press enter twice. And you should see the word done confirmation on your calculator. All right. Probably you're wondering why we're doing that. You will know in a second. Okay. Now I'd like you to go to Stat, Calc. And this is about linear regressions, about lines. Look, there is a command number 4, guys. It says linear regression AX plus B. If you have the newer calculator, it's going to display a screen and it's going to ask you to put the X list in L1, Y list, L2, and then calculate. So you do that. If not, you just see my screen that I'm seeing right now, just press enter. And can you guys see the equation of the line? It says Y equals AX plus B. It gives you A and it gives you B. So the equation of the line, guys, if I write it down right here, watch. It is Y equals, okay, let's round to 2 decimal places, guys. So what would be A rounded to 2 decimal places? 1.26 X plus B, which is negative 3.3. And I also like you guys to take a note of R. I'll explain R in a second. Just can you write down the value of R, which is 0.97. To 4 decimal places, it is 0.9700. Okay. So I wrote down the value of Y. It's right here. Now we're gonna make you do this, put y equals. So again, click here, y equals. And enter the 1.26x plus negative 3.3. So it will be 1.26x. Look, this is x right here, guys. And then minus, this is the minus sign right here, 3.3. And press on graph. You can see the line of best fit, guys. You see that line that was just sketched? This is called the line of best fit. This is the best line that you can get where all the points that you did with the scatter plot will be as close as possible to this line. This is called the equation of the line of best fit. If you notice all the points are very close to the line, that means there is a strong linear relationship between the x value and the y value. Any questions about the line? So this is all done using technology. You will get the line by going to stat, calc, and then number 4, let me do it again with you guys. And here you go. Now let me tell you about R that I put that down. That's very, very important. That's the first part of chapter 9. So R is 0.97. What do we need R for and what do we need R squared for later? But for today is just R. Let me explain what R is. R is a number, it's called correlation coefficient, is a number we get to determine if there is a relationship, a linear relationship between X and Y. What do I mean by linear relationship? A linear relationship means if X is increasing, Y is increasing at a steady rate, or if X is increasing, Y is decreasing at a steady rate. If R is very close to 1, guys, you can conclude that there seems to be a very strong positive linear relationship between X and Y. If R is very close to -1, then you can conclude that there is very strong negative relationship between X and Y. And if R is close to 0, then your conclusion that the linear relationship is very weak, It's all written right here. If R is close to 1, we say there is strong positive linear correlation between X and Y. Correlation, guys, means linear relationship. If R is close to -1, we say that there is strong negative linear correlation between X and Y. When you did the diagnostic on for me, we did it but just to display the value of R. If you don't do it, it will not display the value of R. So that's why we did that. If all the points are full on the line, then R will be 1 or -1. That will be a perfect linear relationship, guys, if all the points are on the line. If R is close to 0, then the linear relationship between X and Y is very weak. We will not calculate R by hand. We will use the calculator, and I did show you how to find R. And these are the directions, guys, and how to find R on the calculator. So if you forget to do it, or if you didn't do it while doing it together, this is how we find the correlation coefficient. It's called the sample correlation coefficient R. What I'm gonna do now, I'm gonna go to the book and show you some graphs, and we're gonna try to guess the value of R based on the graphs, guys. So just bear with me, and then after we do that, we will conclude. All right. So again, guys, a correlation is a relationship between two variables. The data can be represented by order pair XY. X is the independent variable or called the explanatory, and Y is the dependent variable called the response variable. Okay. What happens here, guys? As X increases, Y decreases. They have a very strong relationship. And how do I know the strong relationship? Because if I draw this line here, most of the points are gonna fit, just on the line, or they're gonna be very close to this line. Anyone can guess what would be the value of R here? Just give me some guesses, guys. Remember, there is very strong negative correlation between X and Y here based on the graph. What's your guess of R? What would R be here? Don't be afraid of just saying some values. As long as you make it negative, negative 0.90, yeah, I think probably it's higher also, probably negative point, in absolute, negative 0.97 or 98, because they seem to be very, very close together. So yeah, that's not a bad guess. What about number 2, guys? What do you think? I'm not asking you to find the exact value of R. That's impossible for you. You need all those values, X's and Y's, to put them in the calculator to find R. So would you guys agree it is going to be pretty much the same as this one, but on the positive side? So it'll be probably plus 0.9798. What do you think here? See how many of you still remember what I said about when R is close to what? Close to 0. So this is going to be close to 0, guys. Probably 0.1. That's very weak correlation. This one, it's not linear. If you studied intermediate algebra, this is called a parabola. This is not even in our topic. So this is a non-linear correlation. Let me show you some more. Okay, I'm gonna hide the values of R, and well, I couldn't hide them all. So what is R in the first graph, guys? You see, this is perfect. If you draw a line, all of them will fit on the line. It's gonna be 1, look, that's a 1. If you look at the next one, it seems to be a positive. As X increases, Y increases, but it's not very, very strong. So look, 0.81. Not bad, but it's not very strong. Now look at this one, guys. It seems to be positive, but there is more scattered, you know, just widely spread than the previous one. So look what R is, 0.45. This is all done using technology. Look at the next one. R is -1 right here. Here, it looks like very strong negative correlation. As X increases, Y decreases. And look at the R, -0.92. This is weak. And look at the R, that reflects on that, it's 0.04. Just to appreciate the calculator, the R value, which is called the correlation coefficient, is a measure of the strength of the relationship between X and Y. Until 5 or 6 years ago, guys, I used to have students do this by hand. And it's a lot of work. It will take about 20 minutes, you know, just to find the value of R. Now you don't have to do it by hand anymore. All you need to put your X values in L1, Y values in L2, and go to Stat, Calc, Linear Regression, and it will display the value of R for you. So this is just to show you how ugly this formula is to calculate R. One more thing, and we will be done. Section 9.1. All right. This one, he says comment on the relationship. So if you look at number 9, guys, you say there seems to be strong but not positive because the line is pointing down, negative correlation between X and Y. If you look at 10, you say non-linear correlation. It's not linear, it's a parabola, it's a quadratic. What about 11? Can a student tell me what R is? You should know what R is here. It's a perfect. So R is 1 or -1. Would a student type in the answer? It is -1, guys. 12. R, you can see, is very weak. The relationship is very weak, so you can put any value that is close to 0. 13, it seems to be very strong correlation from the positive side, so we'll be very close to 1. You can guess probably 0.95, something like that. But 14, there are no guesses. It's a perfect positive linear relationship, so R equals to 1. So this is the first part of chapter 9. I still need about probably 45 minutes to wrap up this chapter with the second part of it. You learned already how to find R, and you learned how to find the equation of the line and comment on the relationship. Next time we meet, we'll do a complete example and what you should expect from this chapter. And that's it, guys.